Good morning. I don't know how 10.1 went for you. Hopefully you found my video helpful as I explained lateral area and surface area for cylinders and prisms. Today we're going to look at surface area for pyramid and cones. So you're going to want your notes out. And I uploaded a square pyramid net on Moodle. Do you want to have that as I go through the lesson? Other things you could have: a paper plate, scissors. You got a ruler. That's not so bad. So that's kind of what we're looking at. All right, let's pop over to the document camera. Hold on, I forgot to open it. Oh, here. Hold on, sorry. All right, so pyramid cone surface area formula, regular pyramid right cone lateral area formula, etc. So let's take a look at this. We're going to make a net of a cone actually. So I've got a paper plate here, and maybe I can zoom this out just a tad. Maybe that's a bit better. I don't know. All right. So my paper plate, 9 inches. So just draw the diameter here. Or kind of eyeballing it. Now I'm going to cut out a piece here, and it doesn't really matter. I mean, this is not, just like with anything I do, it's not super precise. Ideally, you would cut to the middle. I'm eyeballing the middle. Cut out approximately a 90-degree piece here. Okay, so what I'm doing here is I'm actually making the lateral area of a cone. Because if I take these two edge pieces here and put them together, voila, I have a cone like that. So there's my lateral area, the area of the side of the cone, and then when I make a cone shape here by putting the two ends together, okay, you can see the cone. Sorry, it's cheap paper plate, that's what I say. Okay, obviously I'm missing the base. So now let's think about how could we find the surface area of this. We knew that the diameter of my paper plate is 9 inches. And if we want to find the area of this piece here, well, maybe you're like, I have no idea how to do that. Okay, well, what if I told you, how do you find the area of the paper plate? Well, you'd probably say, no problem. If the diameter is 9, the radius must be 4.5. So the area of the whole plate would be pi 4.5 squared. Okay, so that's easy enough. But now we have this piece here we cut out. And that's why I said I cut it out basically 90 degrees. I did that on purpose because that makes it a bit easier to think of, like, okay, if I'm missing a 90-degree hunk out of my paper plate, that's a quarter of the plate. In other words, I have 3/4 of the plate left. So I can multiply that by 3/4. And that will give me the surface area, sorry, the lateral area. So here we go. Pi times 4.5 times, oops, squared, times 3/4. So we get 47.71. That's in square inches. So that's the area of this piece here. Okay. And then we'd have to find the area of the base to find the surface area. And that's a little tricky. So we're going to hit the pause button on that just a second. Another useful piece of information here, when we talk about cones and pyramids, they have an additional feature, if you want to call it that, when we're talking about them, and that's called slant height. So when you look at your net cone, the net of your cone, and then you fold it up here, you notice that what is this distance here? That's the radius. When you fold it up, it becomes the distance from the base, it becomes the distance from the base edge of the cone to its vertex, the very top. And we call that measurement in a cone the slant height. So, and strangely, we use a cursive L to denote slant height. So, slant height. So our slant height here is going to be the same as the radius of my paper plate, which is 4.5. Okay, so looking here, regular pyramid right cone lateral or lateral area formula, sorry. The formula is 1/2 times the slant height times the perimeter of the base. That's the formula. So if we look at our example here, fine. So 1/2 times the slant height, which was 4.5, times the perimeter of the base. So that would be the perimeter of the base here. And so just like we were able to find the area of 3/4 of my plate, I can also find the perimeter of 3/4 of the paper plate the same way. So if I said, hey, can you find the perimeter of the paper plate? You'd say, oh, that's easy. The circumference of my plate is equal to pi times 2 times the radius, or pi times diameter, which would be pi 9, either way, pi times 9. Okay, but now I only have 3/4. So this is like finding arc length, if you remember. So I only have 3/4 of my circle. So I'm going to take 3/4 times 9 pi, and that's going to equal the perimeter of the cone. Okay, so 0.75 times 9 times pi, 21.21. So P is 21.21, or yeah, there's, I guess we'll just round it for now. So half of the slant height times the perimeter of the base gives you the lateral area. Now, if we did this right, so I'll just grab, there's my perimeter of my base, sorry for the glare, times slant height times 1/2, and we get 47.71, which, hooray, hooray, is the same value we got over here when we were doing it without the formula. So I like to show you how to do it without the formula so you have an idea like what is actually happening, and then use the formula so you know where that comes from too. Okay, now to find the surface area, the formula for that is 1/2 slant height perimeter of the base plus the area of the base. So let's show that before we go to our example. Let's take a look at this pyramid here. It's a net of a square pyramid. And let's just get some crucial measurements here to start. So first we'll get the length of my square here is 2.5 inches. And then the slant height, which is going to be the bottom here to the top, is another 2.5. So L is 2.5. My side length is 2.5. So my area of my base is going to be 2.5 squared, 6.25 square inches. And then, so we can think of like, okay, what would be the area of this square pyramid? Well, we could just find the area of this base, which we did, and then find the area of each of these triangles without using the formula. So this triangle, so the slant height is the height of my triangle. So we know this is 2.5 here, this side here. So 2.5, so half base times height, so half 2.5 times the height of the triangle equals 3.25 inches square. So each of these is 3.25, 3.25, 3.25. So you say, okay, what is the surface area of this pyramid? I just got to add that all up, right? So we got 6.25 here, 6.25 here, 12.5 plus the base, 18.75 square inches. Now, the formula is 1/2 slant height perimeter of the base plus the area of the base. So we knew the slant height is 2.5. The perimeter of the base is 2.5 plus 2.5 plus 2.5 plus 2.5. That's 10. So times 10 plus the area of the base, which is 6.25. What do we get? So half of 10 is 5. 5 times 2.5 is 12.5. 18.75. You can check my math if you want. So we end up with the same answer. So just for arts and crafts, we can cut our square pyramid out. You might not want to watch if one of those kind of people that like has to cut exactly on the line. That was never my strong suit. Given my drawing skills, etc., it's very possible that I failed elementary art. They were going to hold me back, but They just figured that I would never pass elementary art. Maybe you fast forward the video here. Or maybe you're a star student and you printed out the square pyramid net and you're cutting it out yourself because you like the visual aid. I always like in the Dave Ramsey videos, you know, he'll just haul out something and say visual aid, like an umbrella. He says there's going to be a rainy day, so have an umbrella. All right, so there's my net, and then you can, you know, fold on the lines here. Folding, folding. Okay. There you go, boom, here's my square pyramid. Okay, one thing to notice here, I know it's not perfect. One thing to notice here is that, so the slant height, remember, is the distance from the center. So I'm just guesstimating here. The center of the base here to the vertex, that's defined as the slant height. So I'm gonna drop the ruler here just to draw a straightish line. Okay, so that's my slant height. Okay, that's different from the height of the pyramid. The height of the pyramid is defined as the distance from the center of the base, which would be roughly here, to the very tippy top, the vertex at the top of the pyramid. Okay, we could kind of estimate that just by plotting that, you know, plopping one of our sides down. We can say, well, it's about 2 inches. Can't see that very well, can you? No, can't really augment that the right way. We can find it out because we know this distance here is half of 2.5, right? Because it's 2.5 across, so that's 1.25 inches. And we know the slant height, which is actually going to be the hypotenuse, if you can visualize. And then if I height, so this, the height of my pyramid is going to be one of the legs of my right triangle. So you can kind of think of it as
Daddy?
So if you think of like, here's the height of my pyramid, here's the slant height of my pyramid, this is half of the base edge. If S is the base edge. So in our case, we said this is 1.25 inches, because all the way across was 2.5, right? And we don't know the height, we're trying to find that. The slant height, though, we knew because we measured it, was 2.5. So using Pythagorean theorem, 1.25 squared plus h squared equals 2.5 squared. So that's 25/16 plus h squared equals 6.25. So 6.25 minus 25/16. And then we're going to take the square root of that. Oops, silly thing. .165. Sorry, glare. 2.165. Just want to verify here, since I hit alpha instead of second. Yeah, 2.165. That's my height. It's in inches. And that's kind of what we roughly guessed when we tried to measure it with the ruler. All right, now let's take a look at this example. Find the surface area of a right cone with a slant height 13 and a base radius of 10. My suggestion, before I go over this, is you can always hit pause and try to figure it out yourself before you watch me do it. There's my cone. It's got a slant height of 13 and a base radius of 10, and we're asked to find the surface area. So it's 1/2 slant height, perimeter of the base, plus area of the base. So 1/2, 13. Now the perimeter of the base is going to be pi times 2 times the radius. So this is my P. I'm just putting parentheses around that to show you that's what P is. L, slant height, P. And the area of the base is just pi 5 squared. So then we just go ahead and plug that in. So we got 10 pi, 130 pi, 65 pi, and 25 pi. That's 90 pi. Double check on the calculator. Oh. Bueno. That's in centimeters squared. Okay. So going back to my cone, we found the lateral area. What we didn't find is the surface area. This gets a bit tricky, but I'm sure you have your thinking caps on. So what we need to do is we need to find out the area of what would be the base of this cone if it had a base. We're imagining it has a base. What is the area of this circular piece? So if I drew it out kind of flat, we have kind of a Pac-Man looking deal going on, right? And this measurement here is 4.5. And notice when we put these two edges together, we said that the perimeter, we've already figured that out, right? The perimeter of the cone was 3/4 the perimeter of the plate, right? And so that's the 2121 number here, 3/4 of 9 pi. Right? So now we're going to work backwards to find the radius of the base of the cone. That's different than the radius of the plate. Okay, the radius of the plate's 4.5. To find the radius of the base of the cone, we know the circumference of the cone, right, the perimeter of the cone. That's the 2121 number. Okay, we also know that the circumference of the cone is equal to pi times 2 times the radius of the cone. Again, different than the radius of the original plate. So now we're just going to solve this. So we're going to say 21.21 is equal to pi times 2 times the radius of the cone. It's an R. Right, so now we're going to divide. Looking at our equation here, we're going to divide by 2 And we're going to divide by pi, and we get 3.375. So the radius of my cone is 3.375, or 3 3/8. That's in inches. And that makes sense. I mean, it's less than 4.5, right? The radius of our plate. That makes sense because the cone base is going to be smaller, right? If we make this into a cone, this base here is going to be smaller than the size of the original plate. Now we just need to use that in our area formula to find the area of the base. So that's just pi 3.375 squared. So square the answer times pi, we get 35.784. So our lateral area, we figured out, was 47.71. That's the lateral area. The area of the base, we just figured out, was 35.785. And we'll just add those together. So plus 47.71. And we end up with a surface area of 83.49 inches square.
Daddy?
Not right now, Ruby. I see my daughter. She's 4. She wants to learn geometry, don't you, Ruby?
No.
Yeah.
No.
She's saying yes. It sounds like no, but it really means yes.
No. I want to get.
All right. So that's it. That's surface area of cone and pyramid. Hopefully you enjoyed it. And, okay. Hopefully you understood it. And if you have questions, let me know. Here's your homework with the pen that doesn't work. Here's your homework. So section 10.2, 6 through 16. And I'll make a spot on Moodle for you to turn that in. And you'll have till tomorrow to do that. Tomorrow being Wednesday.
Daddy?